For centuries, our understanding of the cosmos was provincial. We looked at our own solar system, a collection of orderly spheres, and assumed we lived in a typical neighborhood. We thought the laws of nature imposed a certain restraint on the formation of worlds. We were wrong. As our telescopes reached further into the dark, they didn't find more Earths. They found nightmares. They found anomalies. They found worlds that push the very boundaries of what physics allows to exist. Meet Kelt 9b. It is not just a hot Jupiter, it is an ultra-hot Jupiter. Located 670 light-years away in the constellation Cygnus, it orbits a star nearly twice as hot as our Sun. The dayside temperature here reaches a staggering 4,600 Kelvin. To put that in perspective, it is hotter than the surface of most stars in our galaxy. At these temperatures, the very laws of chemistry we rely on begin to fail. On the day side, the heat is so intense that molecules cannot exist. Water, carbon dioxide, and even hydrogen gas are literally ripped apart. Only when these atoms are swept to the cooler night side by supersonic winds can they recombine, releasing a torrent of energy that turns the atmosphere into a perpetual global explosion. Kelt 9b isn't just a planet. It's a celestial forge where matter is fundamentally broken. Light is the currency of the universe, but some worlds are bankrupt. Tres 2b is the darkest planet ever discovered. It is a gas giant the size of Jupiter, but it reflects less than 1% of the light that hits it. It is less reflective than coal. Why is it so dark? We believe its atmosphere is thick with light-absorbing chemicals, vaporized sodium, potassium, and gaseous titanium oxide. But even in this darkness, there is a haunting glow. The planet is 1,200 Kelvin. If you were to look at it with the naked eye, it would appear as a dull, burning ember, a faint, red-hot glow pulsing from within a shroud of absolute shadow. Then, there is 55 Cancri e, a super-Earth with a mass 8 times that of our own. Models suggest that at least a third of this planet's mass, roughly 3 Earth masses, could be composed of diamond, a world of unimaginable wealth, forged in the heart of a gravitational vise. On the opposite end of the thermodynamic scale lies Ogle 2005 BLG 390 LB. This is a world where time and motion seem to freeze. It sits in a permanent deep freeze at 50 Kelvin. Here, the concept of an ocean is alien. There is no liquid. Instead, there are frozen layers of nitrogen and methane. It is a silent, crystalline tomb, drifting 21,500 light-years from Earth. Time is the ultimate extreme. In the globular cluster Messier 4, we find PSR B 1620-26b, nicknamed Methuselah. It is 12.7 billion years old. This planet formed barely a billion years after the Big Bang itself. It has witnessed the birth and death of entire generations of stars. It formed before the Milky Way had even fully assembled. It is a survivor of a cosmic era we are only beginning to understand, a relic of the first billion years of time. But if Methuselah is the master of time, Swift J1756.9-2508b is the master of speed. While Earth takes 365 days to circle the Sun, this world completes its year in just 54 minutes. It is a planetary remnant, the skeleton of a star being devoured by its pulsar host. It is a world on the brink of total annihilation, moving so fast that our traditional definitions of orbit barely apply. These are not just anomalies or cosmic curiosities, they are the frontiers of physics. Every extreme planet we find forces us to rewrite our textbooks. The universe does not care about our sense of normal. It only cares about the limits of what is possible. And as we look closer, we find that those limits are much, much further than we ever dared to imagine.